Hello everyone. Okay, so this video we are going to be using trigonometry, specifically the trig ratios, to be solving for angles and missing sides in a right angle triangle. So if we look at here, find the length of the side marked X in the given triangle. So we have one side and one angle, and we're looking for another side. So usually when we were solving for missing sides or right angle triangle, we were using Pythagoras' theorem. But in this case, I don't have two sides to work with. I only have one side and an angle. So what can I do here? Well, I'm looking for this side here. I'm going to use my trig ratios to help me solve for this missing side. So if you're looking up here, my trig ratio, so sine of an angle is equal to the opposite of hypotenuse, the cos of an angle is equal to the adjacent over the hypotenuse, and the tan of an angle is equal to the opposite side over the adjacent side. So I have my angle here. Here it is. So let's find my opposite. Well, this x is going to be my opposite side because it's opposite my reference angle. Therefore, this side is going to be my adjacent because this is the hypotenuse because it's opposite my right angle. So let's have a look here. So I have my opposite, which is x, and I have my adjacent, which is 14. So I have my opposite and my adjacent. Which trig ratio are we using? Well, if you look up here, or if you remember SOHCAHTOA, I'm going to be using tan. So I have here tan of angle 32 is going to be equal to the opposite over the adjacent, which is x over 14. So I have tan 32 is equal to x over 14. So how do we solve for x? Well, I have tan 32 is equal to x over 14. So I'm dividing x by 14. So therefore, I'm going to multiply both sides by 14 to get rid of it. So I have 14 tan 32 is equal to x. So my missing side is equal to 14 tan 32. Now, if I go and check that out and check my answer on my calculator, here's my calculator there. Let's move this over here. So I have here 14 tan 32. So let's put this in. So 14 tan 32 and close. Now make sure up here, ladies and gentlemen, yes, I don't know if you can see it here, but if you have a Casio calculator, most calculators do specify this, make sure it has a D up here, because if it doesn't have a D up here, it's not in degree mode, and it'd be in something else called radians, and you might have done it yet. But anyway, just make sure anyway what up here is D as in degrees, because I'm working in degrees. So if that's not the case, reset your calculator by doing shift 9 for the Casio calculator and then just reset it. But anyway, I'm in degree mode, so that is A-OK. So I have 14 tan 32, put in my calculator, click equals. So I'm going to get x is equal to 8.748. Now, does it tell me to round up? It doesn't, so I'm just going to leave my answer like this. X is equal to 8.78. And does it give me any units? It doesn't. So that's my answer there. So that's 8.748 units. So that's how we find the missing side of a right angle triangle using a trig ratio. Now, a lot of the times, we can solve for missing angles in a right angle triangle using my trig ratios. So I have an angle here, this purple angle here. I'm going to call it A. They're asking us here in the given triangle where the length from with the vertice AB is equal to 9 and the vertice BC is equal to 13. Find the angle ACB, so i.e. the angle made from ACB. So ACB, so draw it out, so it'd be this angle here. Find this angle A. Well, I'm going to use my trig ratios. So what sides do I have here? Well, let me label them. So the side opposite my reference angle is 9, so that's my opposite. Therefore, this one's going to be my adjacent. And remember, this side is always my hypotenuse because it's opposite the right angle and it's the longest side. So I have my opposite and my adjacent. So again, let's look up here. What trig ratio am I using? I'm using my tan again. So I know tan of angle A is equal to opposite over adjacent, which is 9 over 13. Now, how do I calculate what A is? Well, we're going to use something called an inverse. So you might remember the concept of inverse, because the inverse of something is just the opposite. We're undoing it. Like how the inverse of multiplication is division. So if I multiply something by 2 and then divide something by 2, didn't change anything. And the inverse of addition is subtraction. So if I add 5 to something and subtract 5 from something, I didn't change anything. If I square a number and then the inverse of squaring a number is square rooting a number, I in turn have changed nothing about that number. So I have tan here. Tan A is equal to 9 over 13. So the trig ratios have inverses in the calculator. So I'm applying tan to this angle here. I'm applying the tan function to my angle A. So I now want to find the inverse of tan. So obviously it's not something as easy as, like, multiplication division. So we have a special function on our calculator for it. So if I clear my calculator here, so if you see here, let me just drag my calculator over here. So if you see my calculator here, above my sine, cosine, and tan buttons here, like so sine, cosine, tan, above these buttons here, yeah? You see these little yellow symbols, sine to the power of -1, cos to the power of -1, tan to the power of -1. Well, they are known as my trig inverses. So what I'm going to do is I'm going to apply my trig inverse to both sides. So I'm going to apply tan inverse on my left hand side. Remember, what we do to one side we have to do to the other. And then tan inverse 9 over 13. So my left hand side now is going to be equal to A, my angle A. Yeah, because I'm tanning the angle A. So I'm applying tan to angle A, and then I'm applying tan inverse. So I'm essentially undoing what I did. So tan A, tan inverse it, and then I'm going to be left with A on its own. And then my right hand side, I'm going to have tan inverse 9 over 3. Now, we have no way of calculating this in our head, so we need to open up our calculator, and we want to access tan inverse here. So I'm going to click shift on my calculator. So shift tan. So now I have tan open here. I'm going to put 9 over 3. Close my bracket. Make sure you close your bracket. Make sure I'm working in degree mode. And click equals. So there's my answer. 71.565 degrees. Now, does it say here we need to round to the nearest degree? So I have A is equal to 71.565 degrees. And we're rounding. So therefore, A is equal to 72 degrees. Because I'm 71.5, since it's 0.5, we're rounding up. So my answer is A is equal to 72 degrees. And that's how we find the missing angles of a right angle triangle. So we just need to find out which trig ratio we need to use, apply the inverse to both sides, and then we'll solve for our angle. And that is how we do that, ladies and gentlemen. Nice short video. And yeah, on that note, I have nothing else to add. So I'll catch you guys later. And bye.